So, I obviously, each of them, it's really experts in their respective areas. But I think to kind of get to that point, it really would be great, important for people to understand, really about your background. So if you could briefly introduce yourself and share your key responsibilities at your company relating to advancing AI and AI for science. So Haifeng, please, and then we'll go along that, please.
Cool. So a little bit about myself. So I am a computer science by training. Started my PhD in AI 2 decades ago, back when AI was still in the last ice age. And then I joined Microsoft Research 15 years ago, which coincided with the 10-year anniversary Human Genome Project. So I would say at that time, I super foolish and hungry, didn't know how hard biomed is, so I find it very exciting. So I decided, hey, I want to work on this. So I was hired as an NLP guy, but I told my manager I want to work on cancer, and miraculously, he didn't fire me on the spot. So that's basically where I am. So 15 years of battle scar, a little bit tiny of progress, but essentially in the medical discovery space.
Very good. Aaron?
Similar background. So I got my PhD from Cornell. Working on good old-fashioned AI, and then spent a large chunk of my career at Bell Labs and adjunct at Columbia. And then, I think resist the urge to move to the West Coast. Eventually, 2015, moved to Uber and working on machine learning platforms and doing self-driving cars. And after that, a couple of startups and at Amazon. So I've been really working on a lot of the reasoning models for math, coding, and computer use. And sort of 2 years ago, just realized, we're on track to do scientific discovery. Have been really focusing on AI for scientific discovery in the molecular world. Yep.
Hey everyone. I'm Jian Cao. So I got my PhD from Stanford. I actually also came from a theory background. In the past, I've been following lots of work by Terry Seb. Then I joined Berkeley faculty, and I also did a startup before. Recently, I joined NVIDIA. There, my main responsibility is to try to advance the science of post-training, in particular covering the data pipelines, new methodologies, and also the novel applications. So really excited about pushing the limits of capabilities of our AMPs, in particular in new scientific discovery areas.
Hi, everyone. So what I presented is what I do with about 5% of my time. 95% of my time is dedicated to improving the capabilities of the model and actually making this possible. And so in this 5%, dedicated to this is part of the OpenAI for Science effort that Kevin Will is leading. And there I have a role of an advisor, trying to help them to think about how the new capabilities that we have can be used to help scientists in all domains, not only mathematics, physics, biology, how to integrate science workflows into our model and things like that.
Well, very good. Actually, on that note, I want to kind of maybe Sebastian and Jian Cao can answer this question, then I'll move on to the next question. And then, but actually on the AI trajectory, since you mentioned that, how do we view the current trajectory of AI? What are your thoughts and strengths and limitations of large language models? And what research directions are you most excited about, Sebastian?
Yeah, it's a big question. But in terms of where we are, this is why I wanted to give this short 5 minutes presentation, because you see, it solved the problem on which I spent like a month thinking about. It's not a huge open problem in the field by any means, but that's roughly the time scale at which those models can work right now. So the concept that maybe some of you have heard me talk about before, it's not from me, I don't even know who invented it, is this concept of AGI time. So basically, for how long can the AI mimic humans thinking? So I would say GPT-4, for example, was AGI seconds. So anything that a human could do in a few seconds, GPT-4 could do. And then as we went to O1, that was mentioned this morning, we certainly in mathematics, we moved to AGI minutes, maybe with O1. And then we went to the models that could solve IMO question and got the IMO gold medal. That's kind of AGI hours. If you're given an IMO problem, it's roughly an hour. Now we are at AGI at least days, maybe weeks in some cases. But that's roughly the state of the art at the moment. Now, somebody this morning was asking, like, why is it that those models haven't invented a new field yet? Or, even Terry was asking about very, very hard question, that it's not there yet. And obviously it's not there. Like, there is some completely miscalibrated expectation here. If you want to solve a really hard problem, I did it a couple of times in my life to think for a long time about hard problems without solving them, on the contrary to Terry. And these are years of thinking that you need to do. Models cannot do that at all. We're limited at weeks. So this is like a starting grad student project that they can do, nothing more than that. Now, in terms of, for the second part of the question, just on limitation, by the way, I think there are no limitations whatsoever. I don't see any limitation. In terms of exciting research directions, I can't tell you exactly what we're working on, but what I can say is there are many interesting research directions. I would say at least I see at least 10 directions which are kind of orthogonal and really interesting, and all of them have the potential to make real progress. At least 10. And this is just from what I see personally. So really, I used to say, and I will conclude with that sentence. I used to say that there is work for a generation of scientists to understand deep learning and to make progress, etc. Now I think there is work for a century, at least, to kind of, understand everything from what we're doing and kind of push them to the limit. So
can you give us one example of an interesting direction? You said you have 10. Can you give us one?
Yeah, I already gave you one. It's the hardness question. So, right now, if you want to solve a problem, you can go and ask GPT 5.2 Pro. Okay, that's one thing you can do. But you can make many calls in parallel. You can have, another model that goes and try to merge them. Using the model as an API and kind of building an algorithm that is leveraging the model as an API call. That's one direction. Yeah. Okay, I will stop here.
Chantal?
I think super exciting. Similar to Seb, I'm also super bullish on the capabilities of AI. Maybe I've emphasized a bit more on different aspects of AI. So we have been talking a lot about language models. There's also multimodal models covering maybe speech, video, images. There's also physical AI, actually embedding the models in the physical world. My understanding is that actually the progress in many other fields, in particular the attempt of combining all the modality together, is still very, very limited. So generally, I'm super excited about the productivity gains those AI can actually give us, in particular after we integrate all these capabilities together. So if we think from this perspective, then the work in AI just started. Right, so we're very, very far away from realizing the full potential. So I'm super excited about this.
Very good. Now, I think that I'm going to ask the next question, which a lot of you guys probably would care about, because it's actually kind of, we said it's academia as well as industry, and it's about production gap. So I want both Aaron and Haifeng to answer that question. What's the biggest hidden challenge when moving an AI model from a research prototype to a large-scale production system? How can we better bridge the gap between lab and industry?
You want to start?
How about you go first?
Yeah, that's an awesome question. So I was in Davos in January, and one of the buzzwords in Davos is about so-called capability overhang. So basically what it means is that a little bit like sort of what Seb alluded to is like, if you look at the underlying technology potential, they actually grow very, very fast, right? But when you look at the real world kind of impact, they actually progress much, much more slowly. So there is a kind of like growing gap between what might be possible and what we actually get to today, right? So, and on that front, I like to kind of think about sort of like a little bit about the AI applications spanning sort of like this spectrum about what I loosely call the productivity gain versus creativity gain, right? So the productivity gain is sort of the boring stuff, like sort of what Taryn talked about earlier, right? Like automating kind of chores or mundane stuff, right? And these are human experts perfectly capable of doing it, but just very tedious, very expensive, very long time. I would say that is the region where actually a lot of this productivity productization gap is going to close very rapidly. One of the areas in medical discovery is the whole clinical trial process. So there are so many things, if you look under the hood, it's unbelievably inefficient, right? And there are so much of that. Actually, arguably, technology already there. So you basically need to figure out some of the mundane stuff like change your management, reimagine the process, workflow, ecosystem, business model. But actually technology arguably is ready. But then there is another even much more exciting thing, which is the creativity game. This is arguably where actually no human being can ever get to the point. Like can you imagine a doctor being able to internalize 8 billion people multimodal longitudinal patient journey, right? It's very hard, right? So, but AI can potentially get them to there, right? And so obviously there, I would say the gap could be grow even larger for a long, long time until actually we were able to actually materialize some of that. I show a couple of examples that, in the multimodal space, echoing sort of Gentile's were. I would say longitudinal, that's a holy grail. Can we actually build a weather forecasting system for a virtual patient, right, to predict what exactly would happen to the patient? If we can get to even some decent accuracy, we get to very close to precision health. And obviously, we're not there yet, right? But that's actually why it's such a really exciting.
Great. Thank you. Aaron?
Yeah, I think I really agree with Haifeng. I just want to add on to the creativity gain. I think the model is sort of getting to the point where it can start helping on the creativity side. But I think we have a huge gap of the model capabilities. So yeah, I think the model has to really get better. So essentially, I've sort of given any problem that they should be able to get better at proposing the right hypothesis, and then to essentially building an agentic system that can carry out these experiments. I mean, these experiments could be sort of in silico, and then could be, like at some point when, like you said, when the when the model is very sure, we can just move to the wet lab or have a lab in the loop. So I think all these sort of infra sort of tools hasn't been built out, right? So in order to really close the loop on creativity, or really sort of you need to build this whole closed loop, and together with models, better capabilities of proposing good hypothesis. Yeah.
Right. So good to hear. But actually, on a related matter, which is something that you guys probably care about, because we're in actually, in fact, earlier we talked about the earlier panel about the human value in the AI era. So actually, in fact, Sebastian, I'm going to put you on the spot, and perhaps whoever you guys out of the three, whoever wants to answer that question, please volunteer yourself. But the question is, many people worry that if AI becomes more powerful, researchers or anybody might lose the value of their own jobs, right? What are your thoughts on this? And what do you believe made in the unique role of human researchers, right? So Sebastian, put you on the spot, please.
Sure. Yeah, so, I personally see like 3 roles of science, and maybe there are more that I'm not aware of, but, one of them is to act on the world, to be able to make us humans more powerful, to create more things, that's kind of technology. Another aspect is really science for kind of the pure reason of understanding the world that we live in. It doesn't matter if it makes us more powerful. It's just, solely focused on the understanding aspect. And then there is a third one that I alluded to this morning when there was a question about chess, which is, science is also very fun to do, like fun in a game sense, and with any game comes competition, and you want to be, the smartest and the fastest and all of that. And this is definitely a big bucket that I don't think should be discarded. So there is competition, understanding, and kind of technology. So depending on which one we're talking about, there will be different impact. So for the technological aspect, it's all about what we can build. So in that respect, AI just makes us even faster, even better. It's just benefit for everybody. We will be able to build even greater things. Wonderful. For the competitive aspect, I do think that it kind of kills the game. And the people who are in it for that reason, maybe it will be like chess. They will still do it in their spare time, but it will be much less prevalent, I think, in the future as kind of a reason to choose that as a job. And then the one that I personally care the most about is the understanding piece. And for that, I think AI, it's not the full picture. Like, it doesn't necessarily, as we discussed, when it comes back with a solution and you don't understand why, or, in my example, I don't understand where the identity came from, this remains unsatisfying, and we want to push further. And so in that respect, I think I'm hoping that in the future, AI will force us in the scientific community to put back understanding at kind of as the center focus of our enterprise. There's technology on one side, that's a different thing. But for the pure scientists, understanding should remain more important. And one thing that I tend to say is, maybe we should write less papers. In the future, what is our unique human expertise? It's not to write more papers, because AI will be better than us at that. But it is maybe to kind of consolidate all of this knowledge and to explain it in a way that other humans can really appreciate and understand. So I think that's my answer to your question.
Okay, I like that. Hopefully you want to answer that, please.
Can I? Yeah, I want to kind of build on what Seb mentioned and say maybe 3 points. First, I would say my old job has already been replaced, so that makes me fearless. Because some of you might know that I was training as an NLP guy, and my first half of my career was biomed NLP, trained some of the early biomed LLM. So when I saw GPT-4 in the 10 a few months before the release, I know my job is done there, right? So I have to find another job. But on a more serious note, I would say is that to me, obviously it's kind of like there are all kinds of serious questions about how the AI will fundamentally change the nation state and the society and all those kind of things, right? But to me, there is also a much more immediate point and kind of like doomsday scenario, which is that the loved ones or my friends and so forth come up telling me that they have cancer, for example, right? So I just have an old colleague in MSR to have, colorectal stage 4 with lung met, right? So very depressing to think about. Pretty much nothing can be done there, right? Despite all this fuss about AI. So for me, like the most immediate thing, I'm hoping that AI will replace my job there to solve cancer. And next, let's solve Alzheimer, neuro, right? Autoimmune, we have no clue yet, right? So, but I think, so that's my second point. My third point is that when I think about long term, is like, I think about AI as a very, very powerful tool. So for example, if you got so it can tell you something like how. But the question there is also a what and why, right? So for example, if I build a perfect virtual patient, I can predict exactly what happened, right? On one hand, you can use it to do precision health, right? On the other hand, you can do it like for insurance company to deny your coverage or claim, right? So how do we actually think about that? I would say part of that is like, I hope the human would actually dictate the value proposition there.
Okay, very good. I have one last question, and I want to open up for Q&A because I do have other questions, but as I said, I want to make it interactive. And my last question, I want everybody to answer, and because I think you guys will all care about my last question, which is, as SAIR Foundation, aims to build a collaborative ecosystem for science and AI, what do you see industry, academia, investors, and the foundations, which is all of us, working together to build this ecosystem? What role do you envision for your own company in this partnership? So, Sebastian, start with you and then come back this way.
Yeah, well, I don't know, but one thing that we do have at OpenAI is a lot of compute, and so we do have more than 4 GPUs. So what I could imagine is, in the future, if we really realize this dream of being able to transform compute into intelligence, which is not at all an obvious thing to do, not automatic, there are some limits to it, but if we can really keep doing it at scale, then we could imagine like that academia and other partners would choose problems that they really care about. They come up with a consensus, okay, we want to spend that amount of compute on this specific problem, and then we help realize that. So I think that would be one possible collaboration in the future. For the moment, just before the grand dream, you can just think, let's say we can select a few mathematical problems that we care about, where we could do the hardness that I talked about, and maybe do it for a week instead of 2 days, and things like that.
Okay, very good. Thank you. Jiantao?
Yeah, I would say that maybe organizations like SAIR could help shape up some agenda for collaboration between academia and industry.
Yeah.
I do want to emphasize that NVIDIA has an academic grants program. So currently offers Hopper H100 GPUs. So maybe one possibility would be that academia and industry, we can work together to figure out what would be the most exciting projects we can work on together. And then I think every quarter we have a call for proposal. Generally, the researchers will have access to GPUs, our cloud, for at least 6 months. There will be some mutually agreed upon projects we can work on. I think it's a great way to actually collaborate. And through this approach, we can also try to figure out what will be the most critical questions academia can work on that will have the outsized impact on the overall community.
Great. Great. Aaron?
Yeah, I'd say we have similar programs. ARA, that's like biannually. Yeah, I think we've fund a lot of research that we think are really promising, uncertain, and industry really doesn't really want to throw resources. So, we want to learn from, a lot of the results. We've got tighter sort of interactions these days. We're just trying to expand sort of the kind of collaboration that can be done between, Amazon and the universities. Yeah, I think the key is to sort of really some promising directions, and then only sort of university has the freedom to kind of look at. Yep. Mm-hmm. Really sort of SAIR can sort of connect and do the bridge. Yep.
Okay, great.
So first, I want to call out Sam Martin sitting right there, who actually is my partner in crime in doing strategy and partnership. So feel free to harass him in the break. So I would say that one of our aspiration, obviously, that's shared by the community is like, how can we build this continuous learning health system, right? So, and when you think about it, obviously, it takes way more than a village. So, and I would say at least 2 things I can easily take off is like, one is like, there are the foundational research side. To some extent, that's like going from 0 to 1, right? Turning what's technologically impossible yesterday to kind of like what could be plausible tomorrow. And on that front, like we kind of benefit tremendously with tons of academic research. And then another kind of collaboration, obviously, is like all this kind of like, involve like patient data and everything. So that has to be obviously the privacy, compliance, and so forth. So that we actually work closely with all the key stakeholders like big health system like farmers and so forth to actually to make progress together. I would say the hardest one is the last bit, which is like, how do we take all this insight, all this de-risking, to actually generalize to 8 billion people, right? To actually apply to a societal level. And I would say we have all kinds of questions and we don't have answers. So we'd love to pick all of your brain there.
All right, picking all your brain now. So right now it's time, well said. Questions, Paul, and then Dima.
Since you're mostly outside of academia, you can freely speculate in a way that some of the deans in this room cannot. So how would, we are 7 months away from fall 2026 semester. What is one radical change you'd recommend we make? Abolish departments, for example. Just to give you a sense of the scale.
All right. Maybe I would make a very brief comment to kind of start. I would say we have interacted with a lot of medical school folks, right? And also New England Journal of Medicine. I think this is basically a big top of mind. It's like we have to rethink the whole education, right? For like medical obviously given the AI, right? So there are some mundane analogy. It's like, hey, we have calculator now, right? So we do very differently when we think about arithmetic. And there are all this breathless hyping about how GPTX cross medical exams or Gemini or so forth, right? So we have to rethink the entrance exams and so forth. And then in medicine, all those folks teach me about how right now they spend like months literally come up with some vignette to teach how students think about diagnostics and so forth, right? Now, on one hand, AI can potentially sped that up to seconds, right? On the other hand, like I think one of the early speaker, I forget who in the morning, talk about what does it mean by learning, right? What kind of skill, right? So again, I don't have answer, but I think about my kids and so forth, like how should they learn in the future?
So maybe one concrete thing is first, don't abolish anything. That's not a good idea. I mean, seriously, again, we don't want to we want to be in control eventually. So remain in control, we need to have the full expertise to understand everything. We cannot have AIs make decisions for us that we do not understand. That's not reasonable. So don't abolish anything. Reinforce the value of expertise, explain to all the students that this is going to be ever more important. And then I would say, if there is one addition to make, it's having a course on AI capabilities would probably be a good idea. Trying to explain to them how they can use them in many different cases. And importantly, do not tell the kids that AI will never be able to do X, because that never work out very well. So don't it's going to be hard to select the good professor for that class. But yeah.
I love what that comment on that, and then I think you and then Jason, and then perhaps someone over there. We are actually, by the way, so Rich Sutton and I, we're actually thinking of doing summer school, because right now, iterations, right? And then in the future, we'll invite you guys to be part of it. It's like summer program is actually when you have the flexibility to adjust and learn something new, and then quickly, and adjust that, and then boom, we hit it in the next sort of semester or quarter. So well said on that comment. But Dima.
I wanted to ask sort of similar nature. So there's been a big change in how the federal government looks at funding research. And I just wanted to basically ask your perspective on this. I mean, is the industry stepping up to that? Is that something you're worried about? And I also wanted to comment that of all the voices out there, I think it's more likely that the government is listening to industry voices. So that was my other side of the question. Is there any kind of advocacy that you foresee doing in the direction of more increased federal funding for research, assuming it's needed?
Maybe I can say first thing is so I was in an NIH workshop last September. One thing that it feels really depressing is that hearing how NIH basically funded 80% of the biomedical foundation research in the world, right? So to some extent, like U.S. leading benefit tremendously from that, but also subsidizing a lot of those innovation. It's so depressing to see that actually it was time before the shutdown, right? And then I won't go to too much of the other political side, but sort of like I think one thing that I can think about sort of the actionable part is like we need much more education to show, like for example, why vaccine works and why those biomedical research are not waste of money, right? So and all those kind of human stories. So I think right now we are having, like I talk about that capability overhang, right? I think there is also a giant gap, which is like how science is making life so much amazingly better, but people don't realize that, a lot of the folks, right? So I feel like maybe each of us at least have some responsibility to bridge that gap. But to me, like if I get to say, obviously way above my pay grade, but we should fund way more for fundamental research.
Right. I'm going to pass it on to Jason. Go ahead. What's your question?
Hi, great panel. But I have a more technical question, maybe for Sebastian. You talk about trying to understand how AI reference that make conclusions. I know it's like a search problem, right? You stumble some equations, but once you have that, can you start tracing back to see how the knowledge or the result being created? Because you can see where the high attention scores are, and you can keep going back. We cannot do that because we don't own the OpenAI code, and to us it's a black box. But if you are inside, you can have an observability, right, of everything goes on.
Yeah. But there are lots of open source models out there, including GPT-OSS, and these are thinking models. So you can build your own harness and try to solve this problem, within an open source ecosystem. And when you talk, that's exactly the right direction to start thinking. It's step zero, what you said, because the problem is, when you think about the attention, it's within a sequence. But in this harness, you can think there is a kind of tree of sequences. And in fact, it's not even a tree. There are cycles where, some of this chain of thought is being used over there and they connect like this. So it's much more than just within a sequence looking at the attention. It's also looking at, you can think of, it's a network of chain of thoughts. And so how do you study that?
I think it's a lot more exciting to look at something like the GPT-5, which has a higher intelligence level than the open source model. That's why I'm asking that question.
It is more exciting, yes.
Yes. That lady in Utah, go ahead, please. And then Barry.
Kind of a
Yes.
follow-up on that. Like, would you not trust an LLM as a judge approach to this problem?
Okay, great.
What's the question? Repeat that.
The question is, would you not trust an LLM, asked to give the task to an LLM and let it do it? So the problem is the problem is very simple. I told you it's going to write like 10 books worth of words. I cannot put all of that into a context of an LLM. It's not going to do a good job. So then becomes the question, okay, how do I chunk it up? But again, it doesn't have a linear structure. It has this graph structure. So the question starts to be, if you have this graph structure over text, how do you chunk it up to an LLM so that it understands? So again, it's an interesting question. Like the angle that you just gave gives you more, you keep digging. There's more and more questions there.
Utah, go ahead. What's your question?
Yeah, so the question is actually for Jianhao and Hufing in terms of simulation. It's very interesting, and you're doing research in terms of using simulation to actually represent the physical world, so that help us derive the design. And my question here is, how can you handle the simulation, the accuracy simulation for the safety critical applications? How do you guarantee, right? And it doesn't matter whether you go with your world model or you go with precision in terms of minimize the, for the fault path, things like that. This is actually very relevant because literally we're using this for our mission critical explorations. NASA JPL, we test for flight and to forecast. How you handle that? So it's very interesting to hear your insights. Thank you.
I just have a pre-comment. I think that's a super important question. Maybe a problem that will never be completely solved. But when you think about the progress like autonomous driving, initially the simulators we built, the quality was really low. But currently, you already see like Waymo, Tesla Robotaxi, and reliability is very, very high. So I would say that it's really an iterative process. Throughout the process, we refine our uncertainty quantification, refine the methodology of building the simulation, sometimes to reduce cost, sometimes to improve accuracy, then we iterate. Then generally, there also could be new innovations in terms of really pushing the Pareto frontier of the quality of the system.
So maybe I build on that to say a couple of thoughts. So if you look at the simulation, right, so there are sort of maybe a couple different regimes. So the first regime is kind of like the alpha zero, right? Like the classic Rich's work in RL, right? Which is like if you have a perfect simulator, you can generate kind of infinite training data, right? And then you basically how RL work. And so that worked for games, Go, chess, how AI conquer those area. And then for math and coding, there are sort of so-called verifiable rewards. So it's kind of like sort of like not perfect simulator, but kind of semi-okay simulator, right? I would say in medicine, we wish we have that kind of simulator, right? What if we can have the virtual patient from the get-go? We don't, right? Now, there is kind of like this first order approximation, which are all this real world patient journey, right? So again, I kind of semi-making a joke about how for some of those very subtle patterns, like let's say radiologists, pathology, they're very difficult to interpret them. But after 6 months, after 12 months, you get a very clear clarity, whether the patient died, whether cancer progressed, and so forth, right? So to some extent, it's like, again, sort of like this kind of real-world patient journey give you an approximation of sort of like what happened in the real world. So the question is, how do we weaponize that in a good way, right? So to your point, how do we evaluate? Actually, again, for medicine, actually the most important thing is actually less about so-called interpretability, but actually more about so-called evidence-based medicine, right? So how can you design a very carefully designed trial, eliminate all the confounders, and then actually compare whether a treatment actually work or not? Right, so we still don't know like Tylenol or aspirin how it actually work, but we run rigorous trial to figure out, they actually sort of like in the longitudinal work. So I think that's ultimately in medicine that's remain a gold standard.
Terry, you'll be good, please. Barry.
My question's a little bit off the wall.
No questions off the wall, please.
If I think of the great advances of our time, I say AI we haven't seen it all, but it's one. The second one that I anticipate, which isn't there yet, is quantum computing. And I wonder what the effect of, if we do develop quantum computing in the near future, how will that affect this field of AI? How can it take advantage of the fact that we think in terms of not zeros and ones, but more like a quantum computer? So how would it affect this field? As I say, a little bit off the wall.
Yeah, I'm very bearish on quantum computing for AI. Yeah, I don't really see where it's going to be useful, and it's not for lack of trying. Like, the community has looked at it for now several decades, and there is really not much use case in AI. There is a lot of use case in simulating, and I don't need to tell you that, physical models and, chemistry and all of those things. So for that, yes, it will be an amazing tool. But the way, and in fact, this is a more general comment maybe that I can make just quickly. Like the AI is really this, for me, the direction towards AGI, this kind of general intelligence, human-like intelligence that can use tools, just like we can use tools. And quantum computing, a quantum computer is just going to be one tool among many tools that our future AGI is going to use. So that's how I think about it, much more than trying to use quantum computing to improve the AI itself.
Go ahead, Jintao, you want to say something?
Yeah, I'm actually pretty bullish on quantum. Maybe
slightly different. Very good.
Yeah, we do have a pretty big quantum research group, and actually also some really exciting new products released recently on quantum. Yeah, I would say that maybe there will be, as I've also mentioned this, there will be specific applications where quantum really performs very, very well, but maybe a connection with AI then it takes more time to figure out.
Maybe more time.
Maybe more. Maybe one more thing I want to emphasize also regarding some of the previous questions on how we can foster better academia and industry collaboration. I do want to make one advertisement. This semester we are teaching a course at Berkeley showing students how to build from scratch. So actually it's funded by NVIDIA. So we are really showing students the real cutting edge infrastructure. Starting from data collection, pre-training, post-training, building applications, really show them the inner workings of these systems. They don't understand how to build the systems, they also understand how to use the systems in practice. Because one thing, I think there has been some concerns in the community saying that in the past, we ask AI our college or our exam questions in college. 2 years ago, AI maybe scored 50%. Now AI scored 100%. And the concern was that the students are not really learning. So they just give the questions to AI. So once they really understand how AI really works, they could also be more incentivized to really learn themselves. So this could be a topic that we actually explore more together.
So on a high note of bullishness on quantum and AI, I think that's a great way to end. Actually, thank you so much, ladies and gentlemen. And then you guys can come up and share and exchange more comments and questions personally. But thank you so much. We should do a quick picture together, together. So if I could ask yours, Sam, and also Jackie, take some picture with us in the panel. Stand up, actually. Let's stand up and then. Please take a picture.